Welcome to the use of SI units and their prefixes. Okay, so the SI system is a collection of agreed upon units that are going to be used in science. And this means that we can use the same equations, we know what we're talking about, and it's easy to have conversations internationally. It's called SI because it's named after a French phrase, the Système International. In English, that would be the International System of Units. So SI units, so it's originally a French phrase. So let's go through each of these units one at a time. The one that you're probably most familiar with is seconds. So seconds, which is a measure of time. Whenever you need to put time into an equation, you must convert any time that you've got, whether it's in hours or days or weeks or years, you must convert that into seconds. Otherwise, when you put the number into the equation, you will get the wrong answer out. It must be in seconds. And the same is true for all of the other units as well. This is why we need this agreement, because otherwise the equations won't work. So this one over here, this is meters, and that's a measurement of distance or displacement. So we've got meters, which is a measure of distance. If you've got distance in kilometers or miles, for example, you need to convert it to meters before you put it into an equation. You might be also familiar with the kilogram. You might think of the kilogram as being a measure of weight. That is incorrect. It is a measure of mass. Mass and weight are very different things, and you will learn about that in the physics courses. What else have we got? We've got amperes. The ampere, which is a measure of electric current. We've got moles. The mole, which is a tricky one to explain. It's the amount of substance. The amount of a substance. It's most often used in chemistry. So if you're taking chemistry at the same time, you're going to find this concept a lot easier than people who aren't. And essentially, it's a number. It's a unitless number. And the number is 6.02 times 10 to the 23. And that's known as Avogadro's constant. And essentially, 1 mole is that many molecules of a substance. So if I've got 1 mole of oxygen, I have this many molecules of oxygen. And we use this to describe the amount of a substance. We all use that so that we can agree upon it internationally. The Kelvin is a unit of temperature. You're probably more familiar with degrees Celsius, which we do not use in science. You may be familiar with Fahrenheit, which we definitely do not use in science. Fahrenheit is only really used in 2 countries in the world. It used to be used a lot more. It was very, very common. It was abandoned many years ago by most countries. I think the only countries that use it today are the United States and its territories and Liberia. So that's a bit of a weird one. But yes, temperature is measured in Kelvin. If you ever need to put temperature into an equation, you must have it in Kelvin. 1 Kelvin is equal to a change in temperature of 1 degree Celsius. So, for example, if you have to put a change in temperature, then it's okay to use Celsius, because when we're doing the final value minus the initial value, you will get the change out, and that will be the same if you're using Celsius or if you're using Kelvin. So if you're doing a change in temperature, it's okay to use Celsius, but you need to understand when that's okay, and having a better understanding of Kelvin is going to help you with that. Kelvin is very, very interesting. It doesn't go into the negative region. It only goes down to 0 Kelvin. and 0 Kelvin is equal to minus 273.15 degrees Celsius, and that is the coldest temperature that there is. You cannot get any colder. It's known as absolute zero because it is 0 Kelvin. The last one, you don't really need to know for this course, but for completeness, I'm going to write that in now. This is the candela. And it is a description of the amount of light. Okay, when you're out and about buying light bulbs, you're probably not going to see the candela. You're probably going to be seeing a unit called lumens, and that is most commonly used for everyday purposes. So lumens is the measure of the amount of light that comes out of a light bulb, namely an incandescent light bulb. Candela we tend to use for lights that are directional, so torches, laser pointers, things like that. So anything that has a defined direction, we tend to use candela, and if it just glows brightly and gives out light in all directions, we tend to use lumens. You don't need to know that one, and we won't be using it on A-level physics. Okay, so those are the units. Each of those units can be used with a prefix. You'll notice that one of these already has its own prefix, and the kilogram is written with a lowercase k and a lowercase g. If you're studying chemistry, you will probably be using grams to measure mass. In physics, it's very, very important that you are using kilograms, otherwise the equations won't work. The K in front is a prefix, and this is the only SI unit where we are using a prefix with the unit itself. So kilogram is the standard, not the gram in physics. So we've got a table here with the prefixes on. This goes far lower down and also far higher up than you actually need to use in physics. In physics, we only really go up to maybe Peter and as far down as femto. So you can see that there are several others, but we don't need those. So we'll start, should we start at the top or the bottom? Let's start at the top. Okay, so tera. So if I have 3 tera of something, like 3 terahertz, for example, then I have 3 times 10 to the power of 12 hertz. So you'll notice that the prefix can be replaced with that number, times 10 to the power of 12. And that gets replaced by the T for tera. So it's a shorter way of writing things. And you may be familiar with scientific notation. Scientific notation is when you are using these times 10 to the power of features. And there are very strict rules about what is and isn't standard scientific notation. So for example, if I was to write 42, that would be incorrect. And I should be using 4.2 and then adjusting the power of 10 accordingly. In mathematics, they're very, very strict about that. In physics, we're not. We would prefer you to use a number where there is a prefix attached. So if you need to use the 42, that's absolutely fine. We would prefer you to stick with the prefixes. Okay, so that's tera. Giga, that might be 5.7 times 10 to the power of, and giga is 9. And hertz is a good one to use again. Frequencies tend to be in the region of hertz and teras, things like that. And I would write that as 5.7 gigahertz. Okay, and so on. So you'll notice that the prefix is being replaced by the numbers. So if you're typing it into the calculator, you would type this for giga. If you are reading it off the calculator, you would see times 10 to the power of 9 and know that that's giga. So you should try to learn these. They're quite important. Let's talk about kilo and let's talk about grams. So if we've got 5, oh, I've used 5. Let's try a different one instead. Let's have 9.8 kilograms. That would be 9.8 times 10 to the power of 3 grams, except we would never write that. We would always use the kilogram version. If you only have the grams, if, for example, you are given 563 grams, well, we're missing the prefix and we need to put it back in. Now, to go from kilograms to grams, we would put times 10 to the power of 3. To go the other way, we would use times 10 to the minus 3. So the way that this works if you think about it, we've got times 10 to the minus 3, and then we've got the killer, which means times 10 to the positive 3. So really, those two cancel each other out, and we end up with just 563 grams. So if you ever need to go from grams to kilograms, add in a times 10 to the minus 3. Okay, it goes smaller and smaller. In physics, we don't tend to use hecto. We don't tend to use hecto. We don't tend to use deca. We don't really use deci, but they do in chemistry quite a lot. We will use centi, like centimeters, for example, millimeters, micrometers, nano. We go all the way down to femto because femtometers, a couple of femtometers is things like represents things like the diameter of a nucleon. So we do calculations at A Level Physics that involve femtometers. So it's a good idea to know those and to learn them. Okay, you do need to be able to convert from different types of units. And I've got a couple of examples here of ones that you do need to know how to do. So for example, joules, which is the unit of energy, and electron volts, which is another unit of energy. As long as you remember one fact about these, which is that 1 electron volt is equal to 1.6 times 10 to the minus 19 joules, then you should be able to convert between the two. So for example, if we've got 3 electron volts, then what we need to do is we need to multiply by 3 the number of joules that are in 1 electron volt. If we've got a number of joules and we need to work out how many electron volts those are, so let's say we've got 5 joules, then what we would need to do is find out how many 1.6 times 10 to the minus 19 are in that value, and that will give us the answer in electron volts. So find out how many electron volts are in that number. Joules and kilowatt hours. So there is a fairly useful equation for energy and power. You may remember from GCSE that power is energy divided by time, and therefore energy is power times by time. And you'll notice that kilowatt is a measure of power and hours is a measure of time. So if we're ever multiplying a power by a time, then we're getting an energy. So these units, the joule and the kilowatt hour, are both examples of energy. Let's have a look at an example. So if, for example, you've got a kettle that's a 1.8 kilowatt kettle, which is fairly standard. It's a pretty good kettle. I've seen lower powers. And you run that kettle and you know that you are running it for, let's say, 2 minutes. Then you can calculate how many kilowatt hours that is. The first unit is already in kilowatts, but this one would be converting. So what you'd do is you'd find out, well, in 2 minutes, how many hours is that? And then multiply those values together, and you would end up with an answer in kilowatt hours. If you're going to go and convert that to joules, then what you would need to do is find out, well, how many seconds, how many watts, and understanding those and doing a bit of algebra would help you to get back to joules. The most important thing to understand about units is that they always obey the rules of algebra, always. And there is a trick that you can use to get from any unit to any other unit. And a good example would be Let's have a think. Let's do an example of speed. So we want to have meters per second, but let's say that we've got a measurement of, let's say, 10 kilometers per minute, for example. Okay, so 10 kilometers per minute. One of the useful things that we have is that if you have the same value on the top of a fraction that you do on the bottom of a fraction, then the fraction is equal to 1. And 1 over 1, well, that's just 1. And if you multiply any number by 1, the number is not changed. So we're going to use that information to help us make this conversion. So if I've got 10 kilometers per minute, then what I can do is I can multiply that by a fraction where the value on the top is equal to the value on the bottom. And that means that I will be multiplying by 1 and the number won't have been changed. So I want to get rid of minutes and I want to replace it with seconds. And I want the seconds to be on the bottom. So I want seconds to be on the bottom and I want minutes to be on the top so that they cancel. And I'm left with seconds. So what I can do is put this fraction and say 1 minute divided by, how many seconds are in 1 minute? 60 seconds. So this fraction here is essentially like multiplying by 1 because the value on the top is equal to the value on the bottom. So the whole fraction is equal to 1. So that gets rid of the minutes for me and introduces the seconds. I would then want to deal with the kilometers and get that to meters. So I want to get rid of the kilometers. So in order for that to cancel, I'd have to have it on the bottom over here. Here we go. And I want to introduce meters. Okay, so I now need to make the fraction equal on the top and the bottom. So 1 kilometer is equal to 1,000 meters. If I did this, then the kilometers would cancel and I'd end up with meters and the seconds. So the only units that I would end up having, those two cancel, leaving my only units as being meters on the top and seconds on the bottom. Okay, so the sum I would need to do would be my 10 multiplied by 1 over 60 multiplied by 1,000 over 1, and the answer that I would get would be in the units meters per second. Okay, so you can use that technique and that way of thinking and that algebra to convert any unit into any other.